Alright gang, so let's go through this application problem and let's see if we can figure this out. First, with a broken calculator. Let's keep the calculators to the side and see if we can consider this function. The natural log of the natural log of x. And so if I think about the domain and range for this. When we talk about domain of the natural log function, we know that there is no such thing as the natural log of, or the log of a negative number. We know that we can't find the natural log of 0, and so maybe our first instinct might be that the domain's from 0 to infinity. Well, we need to watch out. When you look at this function, notice that the natural log of x is inside of the natural log. So although the natural log of x has a domain from 0 to infinity, 0 exclusive, notice that if that's the case in this problem, then the x value is restricted to 1 to infinity because of where it sits inside the other natural log function. In other words, if we had the natural log of the natural log of 1, we know that the natural log of 1 is 0, right? And we cannot find the natural log of 0. So that's why we're excluding 1 and any numbers less than 1 here. Okay, how about the range? If you consider the range for this function, well, it's a logarithmic function, so we're fairly confident that this will be all reals, since a logarithmic function is really the inverse of exponentials. Imagine an exponential. You know that you can put anything in for x. So there's your exponential. There's no restrictions on x. Inverses, switching the domains and the ranges. Alright, so moving on. Key phrase here, horizontal tangents. So what do we know? Well, we know slopes would be 0, right? So let's consider, in terms of slopes, we know that's a derivative, so I'm going to find the derivative of this. The natural log of the natural log of x, its derivative would be 1 over the ln of x. That's the derivative of the outer, and then the derivative of the inner would be 1 over x. And so what we need to consider here is this: when will this function be 0? Well, if you said never, you're correct. This function cannot be equal to 0 because the numerator is 1, and so there's no values of x that we could put in there that would make this fraction for the derivative 0. And so there are no horizontal asymptotes. There are no horizontal tangents, I should say. Where's this function increasing? Well, that must mean, if the function would be increasing, what would that mean about the slope? If you said the slope was positive, you'd be correct. And so if we're considering this function, is there any time when this will be greater than 0? Remember, our domain for the natural log has to be positive. And so if you're putting all positive numbers in for our x's that are here, according to our domain, then this fraction will always be positive, right? So where is f of x going to be increasing? We could say that f of x will be increasing everywhere, or from negative infinity to positive infinity. And so that kind of answers this question for us. Where is f of x decreasing? Never. F of x will not decrease. Let me try that again. Will never decrease if it's increasing for all reals. Okay, so let's go ahead and see if we can graph this function and see if all of the information that we found so far fits. Alright, here comes the calculator. And there's our function. If you typed it in, y equals the natural log of the natural log of x. Hopefully we can get our writing back here. I don't see it. Not sure where it went. That's alright. And so let's look at the graph and see if everything we thought would actually happen. The graph itself, if you look at Zoom and Standard, there it is. Now keep in mind that the domain from 1 to infinity looks correct. The range here, although it looks like it's cut off there, remember the calculator doesn't like these types of functions, and so this function would continue to go to negative infinity there, so our range is correct. Notice there would be no horizontal tangents. It is always increasing, never decreasing. And so all we need to do yet is to find the equation of the line tangent to it at the point e comma 0. Now our derivative, if memory serves me correctly, was 1 over x ln x. So if I want to find the slope of this tangent line, I can just go ahead and evaluate that at our point e. And so 1 over e times the ln v. Oh, that's nice. We know the ln v is just 1, so our slope for the tangent line will be 1 over e. Now, can we create an equation using that? I think so. We've got y minus 0 is equal to 1 over e times the quantity x minus e. And so that's an application of the derivative of log functions. Okay, at this point, gang, that's about all I have for you. The rest of the period you can work on the homework assignment 3.8 from your book. And why don't you go ahead and just get into groups, and then you can work on that the rest of the period. Anything you don't get finished in class, you can finish tonight for homework. And I look forward to seeing you tomorrow. Hopefully I'll have your quizzes graded and back to you tomorrow. We'll see you then. Have fun.